All right, this is Openstax Precalculus, section 3.7, number 39. Find the x-intercepts, y-intercept, vertical asymptote, horizontal or oblique asymptote of the function, then sketch the graph. And our function is p of x equals 2x minus 3 over x plus 3. So for the x-intercepts, what we do is we find the 0. I'm just going to say 0 because the numerator is a first-degree polynomial. So I just set the numerator equal to 0. And we get x equals 3 halves. So 0, 3 halves is the x-intercept. And then moving on to the y-intercept. For every single function, you follow these same patterns. As you find the y-intercept, you put in 0. So what we're going to do is we set x equals 0. And then you have p of 0 is 2 times 0 minus 3 over 0 plus 3, which is negative 3 over 3, which is negative 1. So we get that 0, negative 1 is the y-intercept. Moving on, vertical asymptote. Okay, p, y equals p of x is undefined when x equals, well, let's write down what we have. Say when x plus 3 is equal to 0, that is x equals negative 3. And that leads us to the vertical asymptote. Have to be a little bit careful. Just because the denominator gives 0 and negative 3 does not mean that's necessarily a vertical asymptote. But the denominator is 0 when you put in negative 3. The numerator is 2 times negative 3 minus 3, which makes negative 9. So it gives a form of a non-zero number, negative 9 divided by 0. That's what leads to a vertical asymptote. When you have plugging in gives you not 0 in the numerator, but 0 in the denominator. That's what gives you a vertical asymptote. And the horizontal asymptote, we use the simple rule is that if the degree of the numerator equals the degree of the denominator, then we're going to get the horizontal asymptote is a fraction of the lead coefficient on the top divided by lead coefficient on the bottom. So we're going to get y equals 2 divided by 1, so we have y equals 2. And that's the line y equals 2. Oh well, might as well just put little boxes around these. Okay, what's the next thing? Then we're supposed to sketch the graph. Is that enough information for us to sketch the graph? Well, could be. I'm going to make a sign chart. But some people don't want to do that, but I'm going to. Didn't ask us to. So a sign chart is a number line, and it's going to be a guide or tell us where, once I'm done with it, it's going to tell us, oh, hold on, what am I doing? It's going to tell us when the function's positive or negative. Okay, so vertical asymptotes x equals negative 3. So I did that wrong over here. So I'm going to put this x equals negative 3 is a vertical asymptote. And then I have a 0 at, okay, so sorry, this is a mistake. This is 0, 3 halves, the x-intercept. It's the other way around. It's 3 halves 0 is the x-intercept. Okay, that's my world is making mistakes. Okay, so the x comes first, then y. So when y is 0, x is 3 halves. And so that's over here. When I put this on the chart, I have a 0 at x equals 3/2. And then what I can do is I can just plot points. And what I do is I plot points for each interval. Say I put in -4. Then I have 2 times -4 minus 3 over -4 plus 3. And why not plot points anyway? But let's see, that gives us in the numerator -11 and the denominator -1, so that makes 11. Then we pick, this was not supposed to be there. Okay. Then we already did 0. 0 was a good one, and we got -1. So look, at -4, we get positive. At 0, we get negative. I'll pick one more. So I pick one from each interval. And the idea is I'm trying to determine whether the function is positive or negative. So, okay, so the function is positive, negative, positive. In fact, without the sign chart, we should have known that. I should have known that because it has a horizontal asymptote at -2. But I just wanted to do the sign chart anyway. Although that is a little bit time consuming, a little bit messy. So probably could have gotten away without that, without doing that. All right, so I'll just have this as y equals 2. It should be a dotted line. And okay, so that's my horizontal asymptote. And then we also have the vertical asymptote is -3. X equals -3. And we have a 0, which is an x-intercept at 3/2. Okay, so, and then the y-intercept was -1. And we also know that the function is going to go positive, then it's going to go negative, and then positive. Okay. So this is 0, -1. Okay, well, I think really also just by the fact that it's near these... okay, let's just look what's going on. The function has to be near the horizontal asymptote. And it's positive. So actually it's going to be sitting up here. Now look, as it gets close to this vertical asymptote, either it can go up or down. Could it go down? Well, how can it go down if we know it's positive on this interval? Moreover, how can it go down without passing through the x-axis? And we know it only passes through the x-axis over here. So therefore, it's going to go up here. And I don't know that it's lying above the horizontal asymptote, but I think it is if we checked it out. Then on this side, it's negative because we did our sign chart. And so because the function is negative to the right of the vertical asymptote, that means it's down here. And then it comes over to the y-intercept, and then it comes over to this x-intercept, and then it becomes positive. So see, the only way you can go from positive to negative, and positive corresponds to above the x-axis, is it's either going to have a jump where the vertical asymptote is, or it's going to pass through at an x-intercept. So here it's negative, which means it lies below. Negative means it's below the x-axis, and then it comes up above, and we get this over here. Now, for this particular problem, here's another method, which I think is not so bad at all, is that you have y equals 2x minus 3 over x plus 3, and both of these have degree 1. And under this situation, we could view this as a translation of the graph y equals 1 over x. And the way we do that is we do long division. Now this might be more trouble than, than it's worth. But, okay, so this graph is -9 over x plus 3 plus 2. So the way you can look at this is you you start off with y equals 1 over x. Really quick, it's like this. Then you write y equals 1 over x plus 3, and that's a shift to the left by 3. And then you look at y equals negative 9 over x plus 3, and that's taking this graph and flipping it over. And then you take the whole thing and add 2 to it, and it's move the whole thing up by 2. So now the thing is, it doesn't really look like this because I got some things wrong on this. Hold on. So let me try to fix that a little bit. But I got some of the basic things right. I got y equals 2, x equals negative 3, and so I got this part right, and this. What I still needed to do is plot some points to get the y-intercept. So you set x equals 0 and get the y-intercept, and it's to find the x-intercept, you're gonna have to set this equal to 0. But okay. So the thing is, what I just wanted to show, this is, out of a lot of books they do this, is that if you have a rational function that is a fraction of a first degree polynomial and a second degree polynomial, we can view this as a translation of 1 over x. We see that y equals negative 9 over x plus 3 plus 2 is a translation of y equals 1 over x. It's a translation also, there's a reflection there. But that's just one way to do it. The other way I think was good too, maybe even better.